Hello everyone, this is Harsha AJ from the Department of Mathematics. So today we will discuss one of the important and interesting topic, that is Fourier Transform. Sometimes this is also called as complex Fourier Transform. So basically the concept of Fourier Transform is used to analyze problems involving continuous time signals or mixtures of continuous and discrete time signals, and this is one of the most important application oriented topic. Therefore, in this particular video, let us try to understand some of the important formula in Fourier transform and few problems. And in the next video, we will discuss problems based on Fourier sine transform, Fourier cosine transform, and how to solve integral equations. So let's begin. Let's start with some of the important formula. So we have three varieties of formula. The first one is Fourier transform. And again in this case we have two formula. One is a direct transform and second one is inverse transform. And the formula for Fourier transform is integration minus infinity to plus infinity f of x e power I u x into dx. And this is denoted by capital F of u. And inverse transform formula is 1 by 2 by 2 pi into integration minus infinity to plus infinity f of u into e power minus iu x into du. So the important observation is here we have to integrate with respect to u, and answer is denoted by f of x. Similarly, we have two more varieties. One is Fourier cosine transform and Fourier sine transform. In the case of Fourier cosine transform, formula is 0 to infinity f of x into cos ux into dx. And remember, in this case we are taking integral only positive quadrant, that means 0 to infinity, and the notation is fc of u. So c represents cosine transform. Now inverse Fourier cosine transform formula is 2 by pi, again here also integration 0 to infinity fc of u, which means Fourier cosine transform multiplied by cos ux into du, and notation is f of x. Similarly, we have Fourier sine transform, again integration from 0 to infinity f of x. Instead of cos ux, now we are dealing with sin ux. So multiply by sin ux, integrate with respect to x, and notation is fs of u. So s represents sine transform. Similarly, inverse Fourier sine transform formula is 2 by pi integration 0 to infinity fs of u multiplied by sin ux, integrate with respect to u, and as usual notation is f of x. So these are the 6 important formula we need to remember. Therefore, in this particular video, let's take some problems related to Fourier transform and inverse Fourier transform, and other problems will work out in the coming video. So let's start with the first problem. The question is like this: find the complex Fourier transform of the following function. What is the function? F of x equal to, it takes two value 1 and 0, 1 for mod x less than or equal to a and 0 for mod x greater than a. And in the second part we have to evaluate integration 0 to infinity sin x by x into dx. So the one very important observation is, whenever they ask to evaluate for the second step, we have to go for inverse Fourier transform, and first one is straightforward. We have to use the formula Fourier transform, we have to find the answer, and for the evaluation part we have to go for inverse Fourier transform. So that is the observation you have to remember in all the problems. And one more observation is, here say they have written mod x less than or equal to a. To come out of mod, the same thing can be written as minus a less than or equal to x less than or equal to a. So that observation is very important. Okay, so let's try to solve this particular problem. So the first part is we have to find the Fourier transform. So write down the formula. So here I have just thrown out of this mod function. Instead of mod x, I have written minus a less than or equal to x less than or equal to a. So as usual, write down the formula first. Formula for Fourier transform is integration minus infinity to plus infinity f of x e power iu x into dx, and the value of f of x is 1 from minus a to plus a. In other cases it is 0, so no need to write. And integration is very simple. Integration of e power iu x is e power iu x divided by I into u. Don't forget to apply the limit from minus a to plus a. So when you apply the limit e power I u a minus e power minus I u a, anyway denominator is constant, that is 1 by I into u. Simplify, e power I theta can be written as cos theta plus I sin theta. Here we have, in place of theta we have u into a. So we can write cos au plus I sin au minus as it is. Similarly, e power minus I theta is cos theta minus I sin theta. So in place of theta we have cos au minus I sin au. So here cos function get cancels. So the answer for Fourier transform is 2 sin au divided by u. So this is the first part. Now we have to evaluate the second term, that means integration 0 to infinity sin x by x. This value we have to find out, and as I mentioned earlier, we have to start with inverse Fourier transform. So write down the formula first. Formula for inverse Fourier transform is f of x equal to 1 by 2 pi integration minus infinity to plus infinity f of u e power minus iu x into du. Substitute the value of f of u. In this case answer is 2 sin au divided by u. So 2 cancels, 1 by pi outside, sin au by u into e power minus iu x into du. Now the next steps are very important. See here, we have to find out the value of sin x by x. So there is no other term, right? But here we have e power minus iu x term. So somehow we have to make this enter as 1. How to make? With substitution of x, we can make this element as 1. When you substitute for u, that is not possible because we have u here also. So only option is we have to substitute some value for x so that this term becomes 1. What is the option? So only option is take x as 0 so that e power 0 becomes 1. So with that reason I will substitute x equal to 0. And when you substitute x equal to 0, obviously LHS is f of x. So by the definition of the given function, f of 0 is 1, right? So it becomes 1 equal to 1 by pi minus infinity to plus infinity sin au by u into du. Simplify. Here luckily the given function is even. When we say the function is even, f of minus x should be f of x, correct? So here when I take minus term here, sin of minus theta is minus sin theta, denominator of minus u only, so minus minus cancels, you get original function. So this the given function is even, therefore this can be written as 2 times 0 to infinity sin au by u. But I want the value of this, you shift these two terms to LHS, therefore we get the answer as pi by 2. So try to remember this. If the function is even, we can write this as 2 times 0 to a. Suppose this function is odd, that means f of minus x is minus of f of x, then answer is 0, remember. So this is required in all the problems. Therefore in this case the answer is pi by 2. Now we will move on to the last substitution. I want sin x by x, right? That means this coefficient should be 1. So for my convenience I will take a equal to 1. So the value of integration 0 to infinity sin u by u into du is pi by 2. We will just change the variable, that does not make any difference. So in place of u I will take x. Therefore 0 to infinity sin x by x into dx is pi by 2. So this is the answer for the given problem. Now we will move on to the next problem. This is the second function. So f of x equal to 1 minus x square, again mod x less than 1. So we can throw out of this mod, we can write minus 1 x less than 1 and 0 in other cases. So we have to find the Fourier transform, and second part is evaluate these two terms. The first one, integration 0 to infinity x cos x minus sin x by x cube into dx, and second one, integration 0 to infinity x cos x minus sin x by x cube, the same as this, but there is one more additional term, that is cos of x by 2. Okay, as usual, first we will find the Fourier transform for the given function, and to obtain these two terms we have to start with inverse Fourier transform, right? Fine. So we will start with the first part. As usual, write down the formula first. We have integration x minus infinity to plus infinity f of x into e power iu x into dx. So here it takes only from minus 1 to plus 1, right, by the definition of the given function. In other cases it is 0. So f of x is 1 minus x square, e power iu x is as it is. Now we have to integrate these two. So this is a product of two function. We will apply Bernoulli's rule. 1 minus x square is first function, e power iu x is second function. So first into integration of e power iux is e power iux by iu minus differentiation of first 1 becomes 0 minus x square becomes 2x. Again integration of e power iux is e power iux by iu, one more iu, so I square u square. Third term differentiation of minus 2x is minus 2, and when you integrate e power iux 3 times you get e power iux by I cube into u cube. Don't forget we have the limit from minus 1 to plus 1. So apply this limit. So I have shown all these steps, try to work out. I cannot explain all these steps. So when you apply upper limit minus lower limit, you simplify, and here in place of e power I theta you can take cos theta plus I sin theta, and in place of e power minus I theta you can take cos theta minus I sin theta. Simplify. Finally you get the value of f of u as 4 times sin u minus u cos u divided by u cube. So this is the answer for first part. Now we will go for deduction. So for that we have to start with inverse. So this is the first reduction we have to get. We have to get the value of integration minus infinity to plus infinity x cos x minus sin x by x cube, right? So same thing, we will start with inverse Fourier transform. Formula is f of x equal to 1 by 2 pi minus infinity to plus infinity f of u e power minus iux into du. Same thing here, only one term, correct? So this term I don't want, e power minus iux, so substitute x equal to 0, e power 0 becomes 1. F of x, substitute x equal to 0. By the definition of the given problem, 1 minus x square, right? But x equal to 0, so answer is 1. So substitute f of 0 is 1, RHS 1 by 2 pi minus infinity to plus infinity 4 times. This is the answer we got, e power 0 is 1. Now this 1 by 2 pi and 4 shift to RHS, you get integration minus infinity to plus infinity sin u minus u cos u by u cube into du is pi by 2, right? So almost we reached this step, right? So now we will try to simplify. Now here we'll check whether the function is even or odd. Actually technically speaking we have to evaluate 0 to infinity, right? So by the definition of the given problem, so this was supposed to be 0 to infinity, okay? So here I have written minus infinity to plus infinity, sorry. So this is supposed to be 0, okay? Fine. So we'll check whether this function is even or not. How to check? Replace u by minus u. So sin of minus u, cos of minus u by minus u cube. Again we get original function, so conclusion is the given function is even. Therefore this can be written as 2 times 0 to infinity 2 u shift to RHS. Therefore we got answer as pi by 4, but in the question they are asking u cos u as the first term, so interchange, so minus goes to RHS. Therefore when you change the variable from u to x, the final answer is integration 0 to infinity x cos x minus sin x by x cube into dx is minus pi by 4. So this is the value for the given problem. Now we have one more deduction, right? We have to evaluate integration 0 to infinity x cos x minus sin x by x cube into cos of x by 2 into dx, correct? We have to evaluate this term. Now the important observation is we have one more term, right? So we cannot substitute x equal to 0 straight away, right? We will see. As usual, write down the formula first. Now when you see the problem here, see we have to get second term as cos of x by 2. That means we have to substitute the value of x as 1 by 2. So when you substitute x equal to 1 by 2, function is 1 minus x square, right? So 1 minus 1 by 2 whole square, you get answer as 3 by 4. So LHS becomes 3 by 4, 1 by 2 pi integration minus infinity to plus infinity 4 times sin u minus u cos u by u cube into e power minus iu by 2. So as usual simplify, you get 2 by pi into the same term e power minus I theta can be written as cos theta minus I sin theta, but the value of theta is u by 2, correct, equal to 3 by 4. Now actually I want the first term only with cos function, right? In the question I don't want sin term. Therefore cos is having a real part, we will take only real part, okay? So when you take real part, what happens? 2 by pi I shift to RHS, so it becomes 3 pi by 8. What is the real part here? This term multiply by cos u by 2, right? So sin u minus u cos u by u cube into cos u by 2, it is 3 pi by 8. Still problem is not over, it is minus infinity to plus infinity. We have to check whether the function is even or odd, so replace u by minus u. When you do that, luckily the function is even, therefore this can be written as 2 times 0 to infinity. 2 you shift that side, you get answer as 3 pi by 16, but I want x cos x first time, so interchange, minus you shift to RHS. So the final answer for the second problem is minus 3 pi by 16. So this is how we have to solve. Let's take one more problem. Same thing, find the Fourier transform of 1 minus mod x for mod x less than or equal to 1 and 0 for mod x greater than 1, and hence deduce that integration 0 to infinity sin square t by t square into dt is pi by 2. So again, first part Fourier transform, to get the reduction you have to go for inverse. Fine. So write down the formula first. The function defined from minus 1 to plus 1, right? So minus 1 to plus 1, integration 1 minus mod x into e power I u x into dx. Now mod x means what? When x is negative, that is minus 1 to 0, we have to take minus, right? Because minus of minus becomes plus. But when x is positive, no need to take minus sign, you have to take plus only. So minus 1 to 0, 1 minus of minus x, f of x value, and when x is positive, that is 0 to 1, f of x is 1 minus of plus x, right? Therefore the first term is minus 1 to 0, 1 plus x e power I u x into dx, and second term 0 to 1, 1 minus x e power I u x into dx. Now both the term we have to integrate by integration by Bernoulli's rule. So integrate this term, simplify, you get answer as 4 sine square u by 2 into u square. So after, be careful with the simplification part, don't make any mistake. So you get answer as 4 sine square u by 2 divided by u square. Now we will go for deduction. So we want the value of integration 0 to infinity sine square t by t square, correct? As usual, we'll start with inverse Fourier transform. It is 1 by 2 pi minus infinity to plus infinity f of u e power minus I u x into du. What is f of u? It is 4 sine square u by 2 by u square, right? So as usual, we don't want second term, substitute x equal to 0. So f of 0 is 1 and e power 0 is also 1. So you get 1 equal to 1 by 2 pi integration minus infinity to plus infinity. I want sine square t by t square, right? So 4 can be written as u by 2 whole square in the denominator, correct? When you simplify, you get the original answer. Now I want only one variable here, so for my convenience I will take u by 2 as t. So du becomes 2 times dt and limits are changed, same as the previous, that is minus infinity to plus infinity. So we got answer as 1 equal to 1 by 2 pi minus infinity to plus infinity sine square t by t square into 2 times dt. So luckily again the function is even, so minus infinity to plus infinity can be written as 2 times 0 to infinity. Therefore after simplification we get the value of integration 0 to infinity sine square t by t square into dt is pi by 2. So this is how we will get the answer. Let's take one more simple problem and we will try to finish. It's a very simple problem. Find the Fourier transform of f of x is x into e power minus mod x. As usual, write on the formula first. It is minus infinity to plus infinity f of x into e power I u x into dx. Now just try to simplify the given statement f of x value. They have given x into e power minus mod x, correct? Mod x means what? When x is 0, we have to take negative. So negative of negative, positive. So when x is less than 0, f of x is x into e power x. When x is greater than 0, no need to take minus, only plus, right? But outside we have minus, so plus into minus, minus. So when x is greater than 0, f of x value is x into e power minus x. So we'll split the function, since less than 0 means minus infinity to 0 and remaining 0 to infinity. First case f of x is x into e power x, second case f of x is x into e power minus x. Since bases are same here, we can write this as e power 1 plus I u into x. Here also bases are same, We can write second and third term as e power minus of 1 minus iu into x. So for both the term, either you apply Bernoulli's rule or integration by parts, both are same. So I have applied integration by Bernoulli's rule or by parts. First term as it is integration of second minus differentiation of first, second integration. And don't forget the first term limit is minus infinity to 0 and second one limit 0 to infinity. And simplify, you get answer as 4iu divided by 1 plus u square whole square after simplification of the given problem. So this is how we have to solve the problems in Fourier transform and inverse Fourier transform. So try to work out more problems, you will get the clear cut idea. Just for your reference, I have given 3 problems here. So try to work out, and once you get the clarity, in the next video we will discuss about the problems based on inverse Fourier sine cosine transform as well as how to solve integral equations. Thank you so much. Have a nice day.